friends, in this video we are going to solve a problem based on interfacing the memory chips with the 8085 microprocessor. So let us start with our problem. So our question is that we have to interface two 6116 ICs with the 8085 microprocessor using 74LS138 decoder such that the starting addresses assigned to the two ICs is 8000H and 9000H respectively. So two memory chips are to be interfaced, and the specifications of these two memory chips is given to us in the question, that the memory chip, it is of the size 2 kilobyte and 2 kilobyte is equal to 2 raised to the power 11 bytes. So 11 address lines are there for each memory chip. So each memory chip is having 11 address lines, and we have to interface these memory chips with the 8085 microprocessor using the 74LS138 decoder such that the address range assigned, or the starting address assigned to these memory chips is, for first IC it is 8000H, for second IC it is 9000H. So let us try to solve this problem. First of all, we will see that we are interfacing the ICs with the 8085 microprocessor. So the 8085 microprocessor, it is having 16 address lines. Because for interfacing, we need to select those memory chips, then only the interfacing can be done and communication can be done between the microprocessor and the memory chips. So for that, we have to address those memory chips. So there are 16 address lines in the 8085 microprocessor. But the memory chips 6116 ICs, they are having only 11 address lines. So out of these 16 address lines, we are going to use 11 address lines for addressing the two memory chips. Okay, so 11 address lines will be connected to each of these 6116 ICs, and the remaining 5 address lines, they will be used to form the chip select signal, because we are having two ICs, so there should be some phenomena to select that memory chip. Okay, so for memory chip number 1, we will have some value of these 5 address lines, and for the second memory chip we will have different values of these 5 address lines. So these 5 address lines, these are used for forming the chip select signal for the memory chips, and 11 address lines, they are used for addressing the memory chips. Now for each memory chip, we have the starting address is given to us. So let's see that what will be the value of these 16 address lines. Now the starting address is 8000H. So when we will write 8000 in the hexadecimal notation, it is 1000, that is 8. Then 8000, so all will be 0000. Okay, this is 8000. In hexadecimal, 4 bits are combined. So this is, if we write 8421, what is it is 8421. So for 8 we are having 1 here, and so 8 into 1, it will be the value of 8. It is 0, it is 0, and this is also 0. So starting address for memory chip number 1, this we are doing for memory chip number 1. Okay. So out of these 16 address lines, the 11 address lines are used for addressing the memory chips. So this is for the memory chip number 1. So let's separate the 11 address lines here. So from A0 to A10, we will have the 11 address lines. Okay, so these 11 address lines, they can take any value from 00 to 111. Okay, so starting address is given to us as 8000. Now if these values are changed, suppose A0 to A10, it can take values like 1 1 1. So these 11 address lines, they can take any value, any combination can be there, like from all the values equal to 0 to all the lines equal to 1. Okay, now out of these 5 address lines, you can see that A14 and A14 and A15, we are going to use, because for interfacing we are given that we have to use a 74LS138 decoder, and this decoder, it is a 3:8 decoder. Means this decoder is going to have 3 input lines and 8 output lines are there. So the 3 input lines for this will be chosen from the remaining 5 address lines of the 8085 microprocessor. So out of these 5, we are using A12, A11, A12, A13 for as the input lines for the 74LS decoder. So the value of these 3, they will be constant. Okay, and the value of A14 and A15, they will also be constant. They are not going to change. So what address we are getting for the memory chip? Combined 4 bits. You will see this is again 8. This is 0 1 1 1. So again 8 4 2 1. So 4 plus 2 is 4 plus 2 is 6. 6 plus 1 is 7. So we are getting 7. 1 1 1 1. This is F. Again 1 1 1 1. This is F. So the address range for this memory chip number 1 we are getting is 8000 starting address, and the last address is 87FF. Okay, so this is for the memory chip number 1, and you can see that this 8000 to 87FF, this is the complete 2 kilobyte of the memory. Okay, now you can see here that the A12, A11, A12, A13, they are always 0 0 0. A14, A15, they are always at the value 1 0. So they are constant for this memory chip. Now coming to the memory chip number 2. So for chip number 2, again we will have the 16 address lines of the microprocessor. And out of these 16 address lines, we are going to use the 11 address lines from A0 to A10 for addressing the memory chip. A11, A12, A13, they will be used for the as an input lines for the 74LS138 decoder, and A14, A15, they will be constant. Now for the second memory chip, we have to use the starting address as 9000, because in the question it is given that starting address is been assigned as 8000 and 9000 for the memory chips. So here if we write 9000, it will be 1 0 0 1. 8421 again, so it will be 8 plus 1, so it will be total 9, and 9000, so all the remaining will be 0. So when you will combine this, you will find this is 9, this is 0, this is 0, and this is also 0. So 9000 is the starting address. Now A0 to A10, they can again take any value, any combination. So the lowest value is that all are having 0, and the highest value will be when all are having 1. Now these 5 address lines, they will remain constant. So it will be, so you can see here that the address which we are getting for this memory chip number 2 is 97FF. So the range for this memory chip number 2 is 9000 to 97FF. Okay, starting address is given to us in the question, and last address we have determined through this memory mapping. Now if you compare these two memory maps for the memory chip number 1 and chip number 2, you will find that A0 to A10, they are taking any of the values, and A12, A13, A12, A11, they are 000 for memory chip number 1, and they are 010 for memory chip number 2. Whereas the A14 and A15, they are always as the constant logic 10 for both the chips. So what the value is changing for memory chip number 1 and chip number 2? A0 to A10, they are used for addressing the memory chips. Then A11 to A13, they are at the logic 000, and for chip number 2, they are at the logic 010. A14 and A15, they are 0 and 1. Here also A14 and A15, they are 0 and 1. So we will use the A11 to A13, these three address lines, as an input for the 74LS138 decoder. Because this decoder, it will have 3 input lines and 8 output lines. Here we will have C, B, A, 3 input lines, and output lines will be Y0, Y1 till Y7. Now in this decoder, if the input is 000, then the output Y0 will be activated. So when input is 000, output Y0 will be activated. If input is 001, then Y1 is activated. If input is 010, then Y2 will be activated. If it is 011, then Y3 will be activated. So all the 8 combinations, they will be used for activating the various outputs of the 74LS138 decoder. Now because we are using here the 3 lines A11 to A13 for this input lines of 74LS138 decoder, so here we will have A13, A12, A12 and A11 as the input lines. So when it will be 0, 0, 0, Y0 is activated. So this Y0 will be used as the chip select signal for memory chip number 1. So when this is activated, memory chip number 1 will be selected. When this input is 0, 1, 0, then the output Y2 is activated. So here Y2 is here. So Y2 will be used as the chip select signal for the memory chip number 2, because when this is activated, because here this memory chip will be selected. Okay, so here the three address lines are used for selecting the memory chips. Now the case is how to use the A14 and A15. Now A14, A15, they are constant for both the memory chips, so we cannot use them for any purpose. They will be used for selecting this encoder. This decoder 74LS138 decoder, it will be selected. We will use A14 for the two select lines CS1 and CS2, which are active low lines. So A14 value is 0. So A14 will be connected with the CS1 and CS2 lines, chip select lines which are active low, and the chip select line which is active high, that will be connected with A15, because A15 value is always 1. So that will be connected with the active high chip select line, and A14, because its value is 0, so it will be connected with the active low chip select lines. Okay. Now let us draw the circuit for this interfacing, that how the 8085 microprocessor is connected with or interfaced with the two memory chips along with this 74LS138 decoder. This is the decoder 74LS138. This is 8085 microprocessor. It is the chip number 1, that is 6116, which is 2 kilobytes memory is there, and this is chip number 1. This is again 6116 IC, 2 kilobytes of memory and chip number 2. Now these chips, they will have the select lines, means chip select lines, which is also known as chip enable line 1, chip enable line first, and this is an active low line. Also these chips, they have another chip enable line 2, which is active high. Now this 74LS138 decoder 3:8, so 3 input lines are there, 8 output lines will be there. This is Y0, Y1 and Y2. This decoder will also have the chip select line, which is G2A, G2B, which are active low, and there is also another active high line, which is G1. Now we know that 8085, it is having 16 address lines. Out of that, 11 address lines we have used for addressing these chips. So A0 to A10, they will be connected with each of these chips for addressing. Then data lines are also connected so that data can be transferred. It has 8 data lines D0 to D7, so they will also be connected with the memory chips. After that, we are having A12, A11, A12, A13. So here A11, A12, A13 will be connected as the input lines A, B, C for the decoder. Now when these lines, they are having the input 0, 0, 0, so Y naught is activated. So Y naught is connected for the chip select signal of the chip number 1. So Y naught is given as the chip select signal for this. Y2, when this input is 0, 1, 0, so Y2 will be activated and Y2 is used as the chip select signal for the memory chip number 2. Okay. Now this is active high. So active high, it is connected with plus 5 volts of power supply. So always the power supply will give us it's the input 1. So it will be selected. Here it will get 0 because when 0, 0, 0 is the input, Y naught, it is the active low output are there. Okay. So output, at the output we will get 0 and all the other outputs will be high, means 1. When it is 0, 1, 0, then Y naught will be 0 and all the other outputs, they will be at logic 1. Okay, so 0 will be provided here and here also 0 will be provided. Now we are left with A14 and A15. A14 is at the logic 0, so it will be connected with the two enable lines of the decoder. A15, because it is always at logic 1, so it will be connected to the active high enable line of the decoder. So it is at 1, it is at 0. Now when the microprocessor, it is communicating with the memory chips, it can read the data from them also and it can write the data into them also, because these memory chips are the RAM chips. So for RAM chip, we are having both the read signal and the write signal. So here we will have MEM R and MEM W. Both are active low and they will be connected to the signals of these chips. When we are reading, we will read from the output enable signal of the memory chips. When we are writing into the memory chips, we will have WE. Okay. So this is how the memory chips, they are interfaced with the microprocessor. First we have to find that how many address lines we will require out of the 16 address lines for addressing the memory chips. The remaining address lines will be used for the chip select signal of the memory chips. Okay, and there can be any logic. Here we are using the decoder because it is given to us in the question. If it is given that we have to use a NAND gate or any other logic gate, so according to that our logic will be changed. Okay. So in this problem, we have interfaced two memory chips, 6116 ICs, which are having the memory size 2 kilobyte and they are the RAM chips with the 8085 microprocessor using the 74LS138 decoder. So I hope that this problem is clear to you. Thank you.